This module focuses on innovation in agriculture as a response to real challenges such as climate change, limited resources, and unsustainable markets. Innovation here goes beyond technology and includes new ways of organizing work, cooperating, and using social and cooperative models. We explore how renewable energy, efficient value chains, and collective approaches can reduce costs and create new value. The aim is to support agribusinesses in improving economic performance while also protecting the environment and society. The module is structured around three areas: renewable energy, value chains efficiency, and social and cooperative entrepreneurship. By the end of this module, learners will see innovation as a strategic tool, not just technology. They will understand how it improves sustainability, efficiency, and competitiveness. They will assess renewable energy solutions and their economic and environmental benefits. They will analyze value chains and supply chain coordination to improve efficiency, market access, and risk management. Finally, they will explore social and cooperative entrepreneurship and learn how to integrate innovation into agribusiness strategies within real financial, technical, and policy limits. Renewable energy is becoming a strategic response to rising energy costs and growing environmental pressure in agriculture. Farm operations rely heavily on energy for irrigation, heating, cooling, and processing, which makes them vulnerable to energy price volatility and fossil fuel dependence. Renewable energy technologies offer practical solutions. They help reduce costs, improve energy security, and support long-term sustainability. When these solutions are integrated into farm management and production systems, they strengthen operational resilience and economic viability. At the same time, renewable energy improves environmental performance, supports climate mitigation, and encourages more efficient use of resources. This directly supports the learning outcomes by helping farmers assess renewable energy options and integrate innovation into agribusiness strategies. Modern farms depend heavily on energy at almost every stage of production. Energy is needed for irrigation, heating, and cooling, machinery, processing, storage, and transport. Because of this, farm operations are highly energy dependent. Most farms still rely on fossil fuels and grid electricity, which creates problems when energy prices fluctuate. When prices rise, production costs increase and profit margins come under pressure. This makes farm businesses more vulnerable to price volatility. At the same time, farms face stricter environmental regulations which raise compliance costs and add pressure to daily operations. As a result, energy use has become a key challenge for farm sustainability, competitiveness, and long-term planning. Renewable energy is agriculture means producing energy directly on the farm using natural sources such as solar, biomass, and wind. These sources are renewable because they are natural replenished. Farms can produce renewable energy at different scales depending on their size and energy needs, and these systems can be integrated into daily farm operations. The energy produced is mainly used for self-consumption. In some cases, and where regulations allow, excess energy can also be supplied to the grid. Using renewable energy helps farms reduce energy costs, increase energy independence, and support environmental sustainability and long-term planning. Solar energy is one of the most commonly used renewable energy sources in agriculture. It is popular because it is flexible, scalable, and more affordable than in the past, making it suitable for many different types of farms. Solar photovoltaic or PV systems convert sunlight into electricity that can be used directly on the farm. Common uses include irrigation pumps, lighting, ventilation, refrigeration, and processing activities. PV systems can be installed on rooftops, farm buildings, greenhouses, or unused land. Because solar systems are modular, farms can start small and expand over time. Where regulations allow, extra electricity can also be supplied to the grid. Biogas and biomass energy systems are closely connected to agriculture. Biogas is produced by breaking down organic materials such as manure and crop residues through a process called anaerobic digestion. The biogas produced can be used for electricity, heating, or combined heat and power systems. An important additional benefit is the digestate left after production, which can be used as an organic fertilizer and helps recycle nutrients on the farm. Biomass energy is different. It uses solid materials like wood chips, pellets, or agricultural residues mainly to produce heat. Both systems support a circular economy by turning waste into energy and improving integrated, sustainable resource management on farms. Wind and other renewable energy technologies can support and complement solar and biogas systems on farms. Wind energy can be used through small-scale wind turbines, but it is suitable only in areas with good and stable wind conditions. Because of this, wind energy is very site-specific, and farms must carefully assess local conditions and technical requirements before investing. Wind systems work best as part of hybrid energy systems. For example, they can be combined with solar or biogas to balance energy production. Other renewable technologies also exist, such as geothermal energy for heating and cooling. Overall, hybrid systems and energy storage help farms increase energy independence, improve efficiency, and ensure more reliable energy supply throughout the year. Before looking at costs and environmental impacts, it is important to understand one key point. Renewable energy works best when it is fully integrated into the farm system, not added as a separate solution. Energy systems must match the farm's energy needs and daily production activities, and they need to fit the production cycle of the farm. Seasonal changes are also critical. For example, energy demand can differ significantly between summer and winter depending on farm operations. When renewable energy is planned strategically, farms can achieve higher cost savings. Random or ad hoc installations usually deliver weaker results. System performance also depends on infrastructure, maintenance capacity, and available skills. Finally, good planning and advisory support are essential to improve efficiency. reduce risks, and build long-term resilience. This slide introduces the economic side of renewable energy investments on farms. Before investing, farms need to understand costs, benefits, and overall financial visibility. The renewable energy systems usually require upfront investment, including equipment, installation, infrastructure, and grid connection. Farms also need to consider operating and maintenance costs, which affect system performance over time. A cost-benefit analysis helps compare total costs with expected financial benefits and shows whether an investment makes economic sense. Two key indicators are the payback period and net present value. They help farms understand how long it takes to recover the investment and whether it is financially viable. Renewable energy investments are not assessed only for their financial results. They are also evaluated for their environmental impact. One major benefit is the reduction of greenhouse gas emissions. By replacing fossil fuels, renewable energy lowers carbon emissions and supports climate action. On farm, renewable energy systems also help farms meet environmental regulations. Biogas systems offer additional benefits by improving manure management and reducing methane emissions, which are especially harmful to the climate. The digestate from biogas production can be used as fertilizer, supporting nutrient recycling and improving soil health. Solar and wind energy systems have a very low emission during operations and produce clean energy once installed. To fully understand environmental impact, farms can use life cycle assessment, which looks at effects from installation through operation to the end of use. Successful renewable energy investments need to balance two things: profitability and environmental responsibility. Economic and environmental goals should be evaluated together, not separately, because focusing on only one side can lead to poor decisions. Some projects deliver strong environmental benefits but need financial support to be economically viable. This is where subsidies and incentives play an important role. Other projects may look financially attractive but offer limited sustainability benefits, and these also need careful evaluation. An integrated assessment helps farms understand trade-offs and identify synergies between costs and environmental benefits. Better results are achieved when renewable energy is combined with energy efficiency measures, since using less energy makes renewable systems more effective. Finally, sensitivity analysis helps farms manage risk and showing how results change under different conditions. Public policy and financial incentives play a very important role in renewable energy investments on farms. Policy frameworks strongly influence whether farms adopt renewable energy because without support, many investments are difficult to make. Public support helps reduce financial risk and manage how upfront costs, making renewable energy projects more attractive and feasible. Common support tools include grants, subsidies, tax incentives, and low interest loans, all of which lower the cost of investments. Some schemes also allow farms to earn income from surplus energy through mechanisms such as feed-in tariffs or net metering. Most support schemes are linked to climate energy and rural development policies. This means renewable energy investments contribute to wider policy goals, not only farm profitability. Even when policies are supportive, farms often face practical challenges when implementing renewable energy projects. One major challenge is administration. Farms need permits, grid connections, and must comply with, with regulations which can be time consuming. There are also technical challenges such as choosing the right system, integrating it into farm operations, and maintaining it over time. Financial uncertainty is another issue. Energy prices can change, and policy support may not always be stable. Many farms also lack technical knowledge, and limited advisory support makes decision making more difficult. Finally, social and organizational barriers can appear, as some people may resist change or feel unsure about new technologies. All these challenges show why carefully planning and proper support are essential for a successful implementation. Overcoming implementation barriers requires an integrated approach. First, simpler administrative procedures help more farms adopt renewable energy. Less paperwork and clearer rules make decisions easier. Second, advisory services and technical support are essential. They reduce risk and help farms choose the most suitable solutions. Learning from other farmers also make a big difference. Farmer to farmer learning and cooperative approaches increase trust and acceptance. Renewable energy should be part of the farm's long-term strategy, not a short-term decision, as this leads to more stable results. Finally, continuous monitoring and planning help farms maintaining efficiency and good system performance over time. This sub-module focuses on agricultural value chains and why efficiency and coordination are so important. A value chain links production, markets, and consumption, showing how products move from the farm to the final consumer. Value creation depends heavily on coordination, logistics, and information flow. When these don't work well, inefficiency appears. Poorly functioning value chains often lead to post-harvest losses, lower product quality, and limited market access. This reduces farmer income and wastes resources. Innovation and better coordination can improve efficiency, transparency, and value addition across the chain. Value chain efficiency matters because it reduces losses and waste, improves farmer income and market access, and supports better quality, traceability, and reliability. In the long term, it strengthens the resilience and sustainability of agri-food systems. This submodule supports two learning outcomes: analyzing value chains to identify efficiency and value-adding opportunities, and evaluating supply chain coordination and its impact on market access and risk management. Agricultural value chains are complex systems with many stages and many actors. They cover the full process from inputs to final consumption, including input supply, production, processing, storage, transport, and retail. At each stage, different actors are involved, and their actions influence costs, product quality, and how value is shared along the chain. Agri-food value chains also have specific characteristics. Products are often perishable, production is seasonal, and quality can vary. Because of this, good coordination is essential. When coordination is weak, problems appear. Poor coordination leads to losses, inefficiencies, and sometimes unfair outcomes for farmers. Understanding the structure of the value chain helps identify where improvements and interventions are most needed. Each actor is the value chain has a clear role, and the way they work together affects efficiency, costs, and risk. First input suppliers provide seeds, fertilizers, feed, energy, and technical services supporting production before farming even begins. Next are farmers and producer organizations. They use these inputs to produce agricultural products and carry most of the production risk. Processors follow in the chain, adding value through handling, grading, storage, and processing. Then come traders, wholesalers, and retailers who connect farm production with markets and final consumers. Finally, support institutions such as finance providers, extension services, certification bodies, and public authorities play an important role. They help farms invest, meet standards, and comply with regulations. When all actors cooperate effectively, the value chain becomes more efficient and value is shared more fairly. Governance and coordination show how value chains work in practice. Governance defines who makes decisions, whose standards are set, and how prices are agreed along the value chain. Coordination can take different forms, from simple spot markets to more formal contracts or fully integrated systems. When governance is weak, problems appear, including inefficiencies, quality issues, and unequal sharing of value. Better coordination helps reduce transaction costs and improve consistency and reliability. Trust also plays a key role. When actors share information and work together, overall performance improves. Finally, collective action strengthens value chains by helping actors manage risks more effectively and create more value for everyone involved. Supply chain efficiency is very important in agri-food systems because it is directly affects cost, product quality, and food availability. When supply chains work well, products reach markets on time and in good condition. Agri-food supply chains are especially vulnerable as products are often perishable and production is seasonal. Because of this, reliance and poor coordination can quickly cause problems, leading to quality losses, product waste, and higher costs. Efficiency is not only about roads, storage, or physical infrastructure. Information flow and coordination are just as important. When actors share information and plan together, supply chains become faster and more reliable. Efficient supply chains help farms and business remain competitive and support long-term sustainability by reducing waste and losses. Logistics and infrastructure are key factors in supply chain efficiency. Logistics includes storage, transport, handling and distribution, and all these activities needs to work well together. Efficient logistics depend on both good infrastructure and strong coordination. When either one is weak, problems quickly appear. Poor storage and unreliable transport increase spoilage and costs, especially for perishable products. Cold chain systems are particularly important. They help protect product quality, ensure food safety, and extend shelf life. A reliable energy supply and technical skills also support effective logistics. Without them, storage and transport systems cannot perform properly. Strong logistics and infrastructure reduce losses and improve overall market performance. Post-harvest losses are not only a technical problem, they are also an economic and sustainability issue. These losses occur at many stages of the value chain, including harvesting, storage, transport, and marketing. One common cause is mechanical damage, often due to poor handling and inadequate packaging. Another major issue is that lack of proper storage. Without cold chains and timely transport, products spoil much faster. Market-related problems also play a role. Price fluctuation or lack of buyers can leave produce unsold. All these losses have serious consequences. They reduce farmer income, lower food availability, and waste resources used in production. Reducing post-harvest losses is therefore essential for improving efficiency and long-term sustainability. Reducing post-harvest losses requires more than just infrastructure. It needs a combination of technology, coordination, and skills. First, better harvesting techniques and carefully handling reduce physical damage and help maintain product quality. Second, improved packaging and appropriate storage technologies slow down spoilage, which is especially important for perishable products. Training is also essential. Skills development helps farmers and workers use technologies correctly and avoid costly mistakes. Coordination plays a major role. When harvesting, collection, and delivery schedule are aligned, delays are reduced. Finally, digital tools support better planning by improving demand forecasting, product tracking, and logistics optimization. Together, these strategies reduce losses and improve overall efficiency. Coordination and governance play a key role in how value chains function. Coordination helps align activities and decisions across all stages of the value chain, ensuring that everyone knows what to do and when. Governance defines standards, prices, and responsibilities, setting the rules for how the chain operates. When coordination is weak, uncertainty increases, costs rise, and inefficiencies become more common. Strong coordination improves predictability and planning helps build trust between actors. Governance structure also shape how value and risk are shared. Good governance leads to fairer outcomes and more efficient value chains. Contracts and organizational arrangements help reduce uncertainty in value chains. Contracts clearly define price, quantity, quality, delivery, and payment terms, so all sides know what to expect. Contract farming is often used to stabilize market access for farmers. It reduces risk and supports better production planning. When contracts are well designed, They encourage quality improvement and investment as farmers feel more confident to invest in their operations. However, problems can arise when there is a power imbalance, especially if producers have limited ability to negotiate. Cooperatives and producers organizations helps address this issue by strengthening bargaining power and improving coordination across the value chain. Digital tools help improve coordination and transparency in agriculture value chains. Digital platforms make it easier to share information on prices, demand, and logistics, helping actors make better decisions. Using real-time data reduces information gaps so everyone has access to the same up-to-date information. Traceability systems are also very important. They improve transparency, build trust, and help meet quality and food safety standards. Digital tools support logistics management by improving routing, inventory control, and coordination. However, digital adoption is not automatic. It depends on skills, infrastructure, and institutional support. When these conditions are in place, digital tools can significantly improve value chain performance. Coordination and digital tools offer strong benefits, but they don't work on their own. Their success depends on enabling conditions. One major challenge is limited digital skills and weak internet connectivity, which makes adoption difficult, especially in rural areas. High initial costs and institutional barriers also reduce participation, as not all actors can easily invest in new systems. Weak legal frameworks and poor enforcement can affect how well contracts work and reduce trust between value chain actors. On the positive side, advisory services and capacity building make a real difference by helping actors use tools correctly and cooperate more effectively. Overall, integrated approaches work best when skills, infrastructure, policies, and institutions align, value chain performance improve.